In this short demonstration, we'll show you how golden records are nominated and maintained. We'll start at the Relationships view. The Relationships view provides you with a visual map of the objects in the platform. This enables you to see the schemas, the related datasets, and the business area reference data or data domains that are leveraged by the schemas. You are also able to see which duplicate matching datasets relate to your data. Within each dataset, you are able to see the data quality and visually compare the data schema and data quality between multiple datasets. Zooming to a particular dataset shows a decluttered view of just that dataset and its relationships in the platform. Expanding the duplicate matching node shows the metadata tags that were used as matching criteria for the duplicate record search. From this visual view of the schemas, datasets, and duplicate matching sets, you can navigate directly to any one of these objects. Let's dive into a dataset and start some analysis. You may have noticed from the visual overview in the Relationships screen that our schema has several related datasets. Let's examine each of these datasets in turn. This first dataset, labeled Gold, is pretty sparsely populated in terms of attributes. Basically, we only have email address, first name, and last name. There is place for an address and a zip code, but there is no data in either of these attributes. This next dataset has more populated attributes. I can now see email address, first name, last name, but the address and zip code are all populated with the string unknown. This won't be very useful information. This dataset, labeled TIN, has more useful data, and as you can see, there are indicators that show that the address and zip codes have been verified as actual real addresses where appropriate. Out of all the datasets we have seen so far, this looks to be potentially the best dataset on offer under this schema. We'll now navigate to the duplicate matching console within the platform. You can see here that we have a search criteria called email address match. Within the search criteria, we can see that there are 11 clusters of matching records that have the same email addresses within each of them. Let's look at the metadata for the email address match duplicate search. Here we can quickly see, via a visual pie chart, that the distribution of clusters ranges from singletons through pairs, all the way through to the highest cluster being an 8. That's effectively one cluster containing 8 record matches. Diving into that cluster for Joe at Smith.com, we can see that across the datasets Gold and Bronze, there are at least a couple of duplicated records, or at least records with that email address. We can also see that there is a cluster for Joe at Smith.com, but where the email address is all in uppercase. Since this simple search used exact matching, it regards that email address as different from the other cluster. Let's look at the first cluster now. We can see that within this cluster, Gold and Silver have no address data, Tin has an address, and Wood has address data, but it's clearly not valid address data. Since our overall objective is to set up a golden nominal store, where one dataset is the dataset to rule all datasets, we need to now perform the nomination. Nomination for a persistent golden record store is done at the dataset level. Nomination is quick and easily done. Additional configuration options also allow you to establish relative trust ratings of related datasets beneath the schema model. Configuring graduated levels of trust in datasets is useful when we get to merging and blending cluster content. Based on observation, we're setting Gold to be the best. Typically, Silver would be next, but we noted that Tin actually had better address data, so we will set them up as of equal priority, followed by Bronze and then Wood as the poorest. Of course, over time, the gradings of these datasets would change, and at any time you can come back and change these settings. The flexibility in the Golden Record Store nomination is that it drives the merge rules for when you do perform deduplication. Part of survivorship rule building may also involve determining that the values of one particular dataset are always to win, or a particular value. The objective here is to more generally avoid having to configure merge rules on a per-cluster basis, although cluster-specific rules can be applied at any time also, as part of manual merge configuration. A rationale for the rule set configuration can also be added to support audit. If we now return to the Find Duplicates Matching console and examine that same first cluster, we can now see that gold is nominated as the golden record. We can also see that the other datasets are designated as subordinate. Looking at the second Joe at Smith.com cluster, we see that there is no presence of the golden nominal in that cluster. So here we might choose to set up manual merge rules, or simply ignore this cluster, recognizing that either we need to correct those email addresses at source and rerun the data, or we need to make corrections within the datasets so that they are forced into the all lowercase email address cluster. Merge rule definition is also straightforward here. You can have the survivor always win on merge, or you can nominate the most common value, the longest string, the shortest string, or the value from a particular record in the cluster. Having now nominated a survivor manually, we can see that the other record is to be merged. We can also see what the end results will look like by looking at the preview record merge. We'll just run a single deduplication job for just this cluster now. With some discrete cluster merges configured and executed, we are now ready to perform the main merge of the duplicate records. If you have the right permissions, you can also look at the job log, and you can see that we have a detailed history of all the deduplication merges that we have performed. Event viewing is permissions-based, and here you can also see what was changed. Events are shown in detail to alternative values in the event log as part of data change log auditing. Let's go and see the results of the merge against the golden record master. We can see that wherever possible, the golden records have benefited from the merge of the TIN dataset. Addresses and zip codes are now there. We can also see that where last names were previously missing, they are now present. Since address data is now appearing in this dataset for the first time, the addresses still need to be verified, but this is easily done through the direct integration with Google Maps. To learn more about the Pretectum approach to customer master data management, simply visit www.pretectum.com.